All right. I should be live, but I require some kind of external validation to know if I am truly live. It's live, Tom says. Okay, then. Think we can trust that. Happy Halloween, everybody. How's it going? With the kids out of the house, Halloween doesn't have the same meaning anymore. Especially living in a forest where nobody comes to our door. Although it'd be super weird if somebody actually made it all the way out here and trick-or-treated. I would be impressed. Could we give them anything? Maybe. That'd be pretty amazing. Yeah, Halloween. Yeah, of course, Halloween in Canada. I mean, I've celebrated Halloween all the way as long as I can remember as a little kid. So yeah, absolutely. All right. Let me just get my stuff ready here. So for those of you who are wondering what it is that you have stumbled into, this is going to be a live recording of my weekly questions and answers show. Your questions, my answers. Now, for everybody else, I say when a question pops in your brain, just write it down. I will gather them up and I'll answer them here. But for you, you have to type your questions right now here in the chat. And I think hopefully Nancy is here. Nancy will be, yeah, there's Nancy. Okay. Nancy will be choosing your questions. So you just like ask a question, post, if you can put a little question mark, but even just ask a question and Nancy will see it and she will add it to the list of questions in the question database. I will then begin the process of answering your questions. I have 4 prepared questions that I'm going to go through first, and then I'm going to go through the rest of the questions that we're doing live. So I don't know what it's going to be. Go ahead, ask questions, ask follow-on questions. It'll be a lot of fun. Now, if I don't answer your question, don't take it personally. The primary reason is because I don't know the answer. Especially if it's like a really complicated question that is beyond my pay grade about multiple dimensions and Higgs boson particle counts in anti-de Sitter space. But so I may just like, I don't know, and I'll just skip that question. But I also try to place my emphasis on people who've never had a question answered before. So if you've had a bunch of questions answered before, I will probably skip you for a while, but if you've got like a really juicy question, I'll answer it. But then I will stick around after I actually record the show and we will do overtime and I'll try and catch up a bunch of the questions that I haven't answered yet. So, we'll go from there. Okay. All right. Let's begin. Something else I was going to say, but I don't remember. Video is recording. Audio is recording. All right, let's get into it. Hey everyone, I'm Fraser Cain. I'm the publisher of Universe Today, and this is, Hey everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years, and this is our question show. Your questions, my answers. Now, wherever you are across my channel, if a question pops in your brain, just write it down and I will gather a bunch of them up every week and I will answer them here. We also do this show live every Monday at 5 p.m. Pacific time. So if you want to have the live question show experience, come and join us. There is always the next event somewhere here on my channel, so you can, I'm sure, click some button to get notified by YouTube, because I'm sure that technology works really well. Now, while I am doing the show, you're going to see a planet name come up from the Star Wars universe, and these are votes. So you can go and pick the question that you thought was the best. Write the name of the planet in the chat, and you can just write the word for the name of the planet, or you can write the word and then begin a longer question. Go ahead, and we will add those up and we will count them here. So last week, the winning question was Zero Chill, who asked, what animal would be our best space companion as we move into a spacefaring civilization? And I think I said crickets. People like the question, the answer. So congratulations, Zero Chill. You had the winning question. So once again, if you just vote, tell us which questions, and that way I'll know what's best for everybody. So, all right, with those rules out of the way, let's get into the question show. Oops. Okay. By Gabtier 11. Hey Fraser, I have a question here. When we see the renders of accretion disks around black holes, we see them glowing very bright. Is it only due to that they are hot, or is it possible because there could be fusion in the open due to the extreme conditions? Thanks. Yeah, so when we see a black hole, right, we're looking at this object that is so intense that nothing, not even light, can escape its grasp, and so it is invisible. And yet, we know that black holes can shine brightly. In fact, quasars, which are supermassive black holes that have active galactic nuclei, where the quasar is actively feeding on material, these can be producing jets that are visible across billions of light years. Some of the brightest objects in the universe are black holes. So, why is that happening? And that is because black holes will accumulate accretion disks around themselves. And like, you could think of accretion disks, like the analogy that I always like to use is like you're in the bathtub and you pop the drain on the bathtub, and it's not like all of the water instantly goes down into the bathtub. Some just circles around, swirls and swirls as the limited exit pipe of the bathtub can slowly try to drain out the water that's in your tub. And it's kind of like that. So you see how the water takes on this circular, it starts to swirl. And it's similar to a black hole, but this is just like an analogy. It's not exactly what's going on here. So material is falling down into the black hole. The black hole is spinning. Material can't go directly into the black hole. It needs to go into orbit around the black hole first. I mean, like some can, if it hits perfectly into the event horizon, it goes straight in. But most of the stuff is doing a glancing blow. And when you think about orbital mechanics, stuff doesn't go straight in. Like if you have a satellite and you are having that satellite orbit around the sun, for example, it's going to follow that orbit forever. And if you give it a kick, if you hit it sideways, you're just changing the orbit. You're not going to cause it to spiral inward into the sun. You're just going to give it a different orbit, and you give it another kick and now it has a different orbit. The only way to make that satellite actually go into the sun is if it has a constant thrust, a constant acceleration that is slowing, I guess a constant deceleration that is slowing it down. So it's got to have like a rocket engine on board. And so you've got all this material that is going around the black hole, and the stuff that is just missing is going into orbit. It's encountering other material that's already there. It's bouncing into itself, and it is essentially removing some of its orbital velocity and trapping it in orbit around the black hole. And more stuff that falls into the path of this region, this accretion disk, gets added to the accretion disk, and the accretion disk gets bigger and larger. And as more and more material falls into it, for like supermassive black holes, it can take on the consistency of a star. Like the stuff that is the most dense, the hottest, is actually starting to perform fusion inside this accretion disk. And that's where you get some of the really bright disks around these stars. They are glowing brightly in X-rays in the same kind of way as if they were a star. And what's really cool about this is you've got this accretion disk that's going around the black hole, And it could go that way forever, right? Like why, what would, as I mentioned, you got to give it some kind of kick. And so what's happening when you sort of really look at it very closely is these particles are jostling against each other. Some particles are getting kicks that are a little bit away from the black hole. Some are getting kicks a little closer to the black hole. And eventually particles are kicked so that they get close enough that they fall into the event horizon and they disappear. And so actually an accretion disk can be very stable around a black hole for a very long time before material gets kicked in and actually falls into the black hole. So, but yeah, they're bright because they're essentially one big star that is around the black hole, that is fusing hydrogen into helium and possibly other heavier elements, releasing enormous amounts of X-ray radiation and other wavelengths out into the universe so that we can see them and know, hey, that galaxy has a supermassive black hole in it. If the sound is too low, that's weird. I wonder why the sound would be low. Is this the... Yeah, okay. Well, so we're recording the audio. You just turn me up. I'm recording my audio just locally, so just turn the volume high. Okay. Next question. Why is this hard? Okay, all right. Tambourine Man. Hey Fraser, since the universe is expanding, shouldn't a wide spectrum telescope see a light trail going from infrared to ultraviolet instead of a fixed point image of a star, like a slow shutter photo of a hue changing car light bulb? All right. Tambourine Man. Hey Fraser, since the universe is expanding, shouldn't a wide spectrum telescope see a light trail going from infrared to ultraviolet instead of a fixed point image of a star, like a slow shutter photo of a hue changing car headlight? I mean, light emitted 10 billion years ago from a star reaches us with a different wavelength and position in the sky than the light emitted by that same star 5 billion years later, right? Shouldn't that draw a light trail? Love your channel, thanks. So this is an interesting question. And this is like, there is a, what's the term? Fallacy. All right. So there's a fallacy that you're making that I see quite a lot. And so I wanted to just gather your question up and add it to the list because I see this so much. And the key is that you said, the light is emitted 10 billion years ago from a star, and it's a different wavelength and a position than the same star emitted 5 billion years later. And the assumption that you're making is that we're seeing the star as it was 10 billion years ago, and then we're seeing that same star again as it looked 5 billion years ago. And that's not true. We are seeing that star at either 10 billion years ago or 5 billion years ago, but not both. And people are able to wrap their head around this idea that when you look out into space, you're looking backwards in time. When we see the sun as it looked 8 minutes ago. We see Andromeda, it's 2.5 million years ago. When we see the cosmic microwave background radiation, it's 13.8 billion years ago. And that we see out in space in this sphere where we're seeing galaxies as they looked 2 billion years ago and galaxies as they looked 10 billion years ago and everywhere in between. And for some reason, this causes this confusion in their mind that they're seeing the same object, but we're not. We're seeing different objects at the galaxy. If you would name it, right, we'll call it Galaxy A, and we're seeing it as it looked 2 billion years ago. We are not then also seeing Galaxy A as it looked 5 billion years ago. We might be looking at Galaxy B as it looks 5 billion years ago, and there's no way to see Galaxy B at 2 billion years ago. They are two different locations in the sky, and that's because the light is being emitted from these galaxies in one spot in the sky, and then those photons are passing us. Right? They're going beyond us. And so we're not seeing them anymore. We're not seeing Andromeda at many different times in the past. We're seeing it as it looked 2.5 million years ago. In the same way that when you hear a firecracker go off a kilometer away. You don't hear a continuous sound from the firework. You hear it once. Now, it happened a few seconds ago, but that sound wave is going past you, and then that's what you hear. It's a snapshot in time. But we do see light changing over time. When we look at those galaxies that are 10 billion years ago, they're a different color than the ones that are closer. And that's because the light, the photons that are being released by that galaxy are redshifted in time. And so, or redshifted in wavelength. And so we're seeing the farther in time we look, farther backwards in time that we look, the more those photons are redshifted into other colors. And what's amazing, like a thing that astronomers can do that no other science can do, is they can look in any direction and they can see a galaxy that is 100 million years old, and then they can see one right beside it that is 2 billion years old, and then right beside that they can see one that is 10 billion years old, and they can see all three and compare. There are three different galaxies, but a galaxy is a galaxy is a galaxy, and so you can kind of compare and look at those three different kinds of galaxies and say, what's interesting about the age of the universe when we're seeing that galaxy at? And I know it's a head scratcher, but it's just important to remember that you're not seeing the same galaxy multiple times when you look out into the universe. Robert Carveth. Why not turn meteors into spaceships? Haul them out and they would be more structural than a tin can. So this is related to the question that we had a couple of weeks ago about how ice is one of the best ways to protect astronauts on a spaceship. That protons, in the form of hydrogen, in the form of water, is very effective for protecting astronauts in space. Rock is good too. And so if you are in space and you hide inside an asteroid, you've actually got a pretty good defense against cosmic radiation, solar storms, any other kind of radiation that you're going to experience out in space. And I love this idea of taking an asteroid, hollowing out the interior of it, and then setting off on a journey to a star system. Because, I don't know, it's kind of like setting off with a life raft that is filled with supplies. When you think about what's in an asteroid, you've got gigatons of oxygen, of iron, of aluminum, of silicon, of hydrogen. You've got water, you've got various, ammonia, you've got all ices, all kinds of stuff locked inside this thing. And so you build this tiny little colony or a tiny little base inside the asteroid, protected from the radiation. You set off on a journey to another destination. You can then start to consume the asteroid as a means of keeping your colony alive for the duration of the journey. It could take you several thousand years, and yet your asteroid is a reasonable home. And go bigger. I mean, if you're going to have to make this journey and you're going to have to keep people alive for a long period of time, for multiple generations, I really think that if you're going to try and keep people on a generation ship, like a small generation ship, something that is like the Enterprise sized, it's bordering on a crime against humanity, right? Like, children are born and they're like, what is my purpose? Your purpose is to procreate and die here on this spaceship. Welcome to the universe. But when we think about Earth, right? We live on planet Earth. We live on a planet. We are consuming energy that is coming into planet Earth. We are consuming the various elements that are located on it. And we don't go crazy and we don't have these existential crises about how our parents have brought us into this world and our only purpose is to make sure that the generation ship makes it to its destination. It's just that Earth doesn't have a destination. But imagine if it did. Right? Imagine if planet Earth was being sent to another star system and it was making the journey through the cold vastness of space and was keeping us alive. And you'd have this whole planet to keep yourself entertained. Sure, the surface would suck, but underground, once you get a few kilometers below the surface, it'd be nice and warm. There'd be lots of things to do. Cities underground. And you wouldn't even notice the time, except the whatever thousandth generation that happens to be there when the planet arrives at its destination. So yeah, I think sending human beings via a hollowed out asteroid, the bigger the better, is like the most civilized way to settle the universe. Rules of Imgur. Imgur? Oh no. How do you pronounce Imgur? Imgur. I've never even had to pronounce it. I am so embarrassed. Imgur? All right, let's see. Imgur. Imager. Okay. There we go. Rules of Imager. Ignoring the pure science fiction aspects, what do you think that the book Project Hail Mary by Andy Weir had an accurate representation of interstellar travel? How close we could get to the technology used in the book? So people have been asking me to do the book club for the channel, and I've decided on the way we're going to do this. And we're going to keep it really simple to begin with. We're not going to be showing up at my house. We're not going to drink red wine. We're not going to agree to read the same book, and then we're going to discuss it because I don't have enough space for everybody. And I'm very far to get to. So my plan for now is that I've created a group on Goodreads, and I will put a link in the show notes. You can go to this group. I'm the moderator, so just ask for an invite and I will let you join it. And then you're just going to hurl book suggestions at me. And we will write them all down and we will discuss them in the Goodreads chapter, in the Goodreads location, in the Goodreads group. And then I will read the books in an order that appeals to me. And then I will report to you on the books. So what will this mean? Those mean that if you have book recommendations that you want to give me, this is a way to do it. And if you want to hear what books I like and what I'm reading, this is the way we'll do this. And I'll probably do them in the QA. I'll stop briefly and I will explain the latest book, give you the book review of the week. So the book is Project Hail Mary, and everyone had been asking me to read Project Hail Mary, and I did it. I read it over the summer, and I loved it. It was a fantastic book. The way I describe Project Hail Mary, like if you liked The Martian, you will love Project Hail Mary. It is really intricate. It is like, the way I describe it is like having a mechanic explain to you why they replaced the engine on your aging European sports car with a custom-built engine that they found in a Tokyo factory, and they had to make a bunch of modifications to this engine to make it fit and work in excruciating detail, and it should suck, but you are riveted. And that is what this is. This is like somebody reading out technical documentation to you that you can't get enough of. And so I really enjoyed Project Hail Mary. The gist is there's a problem with the sun, and humanity tries to solve it by sending a spacecraft out to a nearby star system, and hijinks ensue. And there's a lot of technical issues that face the protagonist, and he comes up with clever ways to solve them with the help of an unexpected ally. I'm not going to explain anymore because everything is spoiling. So, but I 100% highly recommend the book. It has a method of interstellar travel. Again, I will spoil it. So if you haven't read the book, the method is they find a life form that generates photons at an extreme level, that consumes energy and generates thrust at an extreme level, and it works as like the perfect propulsion system, as good as antimatter. And it's incredibly unrealistic that a life form could do this. But it worked really well for the story, and it put a lot of really interesting situations for the protagonist to overcome. So I highly recommend Project Hail Mary. If you haven't read it, do so. It was great. If you haven't read The Martian, of course, The Martian is terrific. Like, the movie was great, and I've heard that there actually is there's a movie coming out for Project Hail Mary with Ryan, what's his face? You know, the guy. No. Yeah. You know, the guy who eats cereal? Gosling. Yeah, all right. And actually, I've heard that there's a movie coming out with Ryan Gosling, which is pretty cool. I'm pretty excited. I would love to see this movie done, you know, an adaptation of the book, and hopefully it's as good as The Martian. So, how accurate is it? Not very, but I love the book, and I can't wait to see the movie. So there you go. Here ends the book club for this week. We'll see you next week when I talk about Termination Shock by Neil Stephenson. Adam Johnson. How advanced are quantum computers these days? I remember a while ago they sort of got 3 times 5 right. Sometimes. I assume they are better than that now. So I was at a conference at Google about 10 years ago now. And there was a lot of really smart people there. And somebody from NASA Ames came and gave a presentation. They had recently bought a D-Wave quantum computer. And the presentation was, we probably think it's a quantum computer, but we're not sure. And the state where we're at right now is we're pretty sure they're quantum computers, but there's a lot that still needs to be understood. So I think, you know, where are we in the quantum computation realm? We're still in the not entirely sure how these things work, where they're going to be more effective than regular computers, if at all, if ever. And, you know, let's talk again in 10 years maybe. But I want to use this question as a chance to shamelessly self-promote an interview that I just did with Lee Feinberg, who is the optics manager for the James Webb Space Telescope. It's a long interview. We talk quite a bit about the current state of Webb. We talk about the telescope that comes after Webb, LUVOIR, whatever it's going to be, and then maybe like the telescope that comes after LUVOIR. And then stuff gets weird. And we talk about the idea of a quantum computer telescope. That right now, telescopes, when they receive photons, all they're doing is they're recording the brightness of the photon, and then they're throwing it away. And they're essentially translating the brightness of the photon, the wavelength, and then moving on. But actually, there's a lot more quantum information that is held in the photon. So what if you could hold on to all that information, have the telescope receive the photons at a quantum level? There's also this idea of quantum teleportation, that we can take particles and we can teleport them quite far away. So the telescope could be grabbing photons, teleporting them to Earth, where they can be studied in a quantum computer. And then there's this other idea of quantum interferometry, where you can have two telescopes that are separated by a long distance. They can both be gathering photons at a quantum level. They can be teleporting their photons to a central quantum computer. And then because of the way these quantum computers work, they can be interfered. They can be like an interferometer. They can be combined together instantaneously, and you don't have to have them being aligned up in real time the way you do with a visible light interferometer, like the Very Large Telescope or things like that. That you can just take one set of data from one telescope, set of data from another telescope. You can combine them on a quantum computer, and they will instantly mash together and give you a result. And so the idea is that you could launch multiple of these telescopes separated by thousands of kilometers. They are teleporting their data feeds back home. You are combining the light, and you are effectively having a telescope that is the size of the distance among them. And so you could, according to Lee, build a telescope that lets you see, say, a planet Earth at a 1 megapixel resolution, you know, like an Earth around another star. That's the same kind of resolution you could get with, say, a solar gravitational lens, except you don't have to send a spacecraft out to 1,000 astronomical units. You just have it in orbit around the Earth or at the L2 point. And you can point it at anything that you like. So, and all of the technology is sort of in the works right now. So it's a mind-bending interview. If you haven't already, listen to this interview with Lee Feinberg. It is one of the craziest conversations I've ever had. on this field, and I think you will get a lot out of it. So that's it. Hopefully you'll get some interesting questions answered about quantum computers in that interview. Fraser Cain using Starlink to get broadband for like one more week. The the guy from the fiber guy came by, and I talked to him, and I showed him how everything was ready to go, and he said, "Okay, well, we'll get you your fiber probably within 2 weeks," and that was a week ago. So I feel pretty safe to say that we will have fiber, 1.5 gigabit fiber, and then I will sell my Starlink. Let's see. Peter McCaskill. If we had enough Peter McCaskill, if we had enough time to prepare, would it be possible to hitch a ride on another Oumuamua type asteroid and drop a probe or something onto it? Sure. In theory, if you had enough time, you could see the trajectory that another interstellar object was going to be make as it came close to Earth or to the sun. You would be able to send a spacecraft off to try to reach it, try to go into orbit around it, send down a lander. It is a bit of a challenge, though, because they're coming in with a very high velocity. They came from on an interstellar trajectory. They're going to be leaving the solar system on an interstellar trajectory. They are moving faster than escape velocity to leave the solar system, which is, compared to the sun, like above 42 kilometers per second. Now, if the orbits lined up nicely, you get to use the orbit of the Earth, which is 30 kilometers per second, going around the sun. And so then you could probably match up with, say, maybe a 20 kilometer per second delta V to try and reach that object. It's tricky. You're going to need just the right object that is going in just the right direction, but it is theoretically possible. Like, we have spacecraft capable of doing that. Falcon Heavy with a little lander right on the top. The key is to be ready, that you don't want to wait while the spacecraft is already leaving the solar system to sit down and go, let's design our spacecraft. Now, that said, it is still possible to reach Oumuamua, even though Oumuamua has now been multiple years that it has come through the closest point of the solar system. It is on its way out, but you could still load up a Falcon Heavy with a teeny tiny spacecraft and launch it at Oumuamua, chase it down, and land on it. It's, there's some other techniques, like you could do a flyby of the sun, multiple flybys of various planets, Jupiter, Saturn, etc. You get quite a lot of velocity, and you could link up with it. Now, it would take you about 50 years, but it's still possible. There's a group called Project Lyra that continuously keep updating on what it would take to go to Oumuamua. And wouldn't it be amazing? Like, this is a object that was formed in another star system and made the journey to the solar system. So you would learn a tremendous amount about not the solar system by being able to study this thing up close. Maybe it's an alien spacecraft. It's probably not. But still, no matter what it is would be a boon to science. But this idea of hitching a ride, I think, is the part that I need to sort of break. And that is because there's no hitching a ride. Like, in space, if you're able to go into orbit around an object or able to land on an object, then you have effectively matched its trajectory. And once you've matched its trajectory, there is no hitching a ride, because you are now flying beside it. And so you have done all the hard work to get to it. And then you're just going to be following along with it forever, or you're going to land on it and follow it forever. So, like, maybe you could get the benefit of landing on Oumuamua, and then you could drill down and hide underneath the regolith to protect your spacecraft from cosmic radiation and other dangerous stuff out there. But beyond that, there's really there's no such thing as hitching a ride. People will use this term all the time. Like, wouldn't it be cool? You just hitch a ride on a comet. No, it would be like driving as fast as another car. Wouldn't it be cool if you could hitch a ride on a car that is going down the highway at 100 kilometers per hour? Well, what you need to do is you need to find a car, have that car go 100 kilometers per hour, pull up right beside that car, and then you would get out of the one car and into the other car. It sounds dangerous. But if you've already got your car up to 100 kilometers per hour, you don't need the first car. You've already got a car and you're just driving it, and you don't need to get out of your car and have all that danger. So there's no benefit, no advantage to hitching a ride. But still, the scientific discoveries we could make on a place like Oumuamua would be mind-blowing. And I think we should absolutely do it. If it were up to me, I would definitely send that Chase spacecraft after Oumuamua. There's some amazing engineering challenges that would teach us a lot about rocketry and sort of pushing the limits, and to just have in the hands of scientists a spacecraft that has been, or to have in the hands of scientists a asteroid or comet that formed in another star system would be incredible. There's even one idea that you could bring a sample home, that you could, with the right spacecraft, you could even still land on Oumuamua, gather up a sample, and bring it home within the laws of physics as we understand them today. Like, it's within our capability. Can you imagine that? A sample return mission from an interstellar object. That would be crazy. Snars tax. Other than our view of Andromeda, what source is there for the existence of dark matter, dark energy? I'm not sure how useful our view of Andromeda is for the existence of dark matter, dark energy. I guess maybe the rotation speed of Andromeda wouldn't be possible if it wasn't for a giant halo of dark matter around the galaxy. But let's break them up. Dark matter, of course, is this mysterious mass that interacts with regular matter through gravity, but doesn't release any kind of electromagnetic radiation. It appears to be the dominant form of matter in the universe. And then dark energy is this mysterious force that is accelerating the expansion of the universe. It seems to be some kind of constant outward pressure that appears in every single cubic meter of the universe. The more space there is, the more dark energy there is, and it is the dominant source of the universe. Like 70% of the universe is dark energy. So how do we know these things are true? And like, it would take me in a whole episode to run through the chain of evidence that got us to the point that the modern understanding of dark matter and dark energy. But I want to point you to a recent interview that I did with Dylan Brout from the Pantheon Plus collaboration. And what they did was they measured 1,550 type 1a supernovae, which are a certain kind of star that goes off with a very certain kind of brightness. And when you see one of these, you measure the brightness, and that tells you how far away the thing is. And with 1,500 of these, they were able to measure the expansion rate of the universe at different points along its history. And what they were able to find, to a level of accuracy that, you know, no other sciences can really do. So to 5 sigma accuracy, in other words, there's a 1 in 3.6 million chance that they're wrong. They were able to measure the ratios of matter to dark matter. So how do you measure the amount of matter to dark matter and measure the sort of total quantity there? And so what they did was, essentially, when you think about the Big Bang, you've got all of these galaxies that are spreading outward after the beginning stages of the universe. The question you want to ask yourself is, well, you've got all this mass. Is this mass, you know, who knows what set it off in the first place? You know, Question mark, question mark, question mark. But it is definitely getting less dense. Things are definitely moving away from each other today. So if you add up all the mass of all of those objects, can you get a sense of whether or not they're going to come together? They're going to slow down through their mutual attraction and eventually just form one giant ball somewhere in the universe. Maybe a big crunch. And so astronomers sort of calculated the mass of the universe. And the way they did that was by measuring these type 1a supernovae. They were able to see how fast the universe was expanding at different points in its history. So you've got a bunch of type 1a supernovae that are close by. You've got more type 1a supernovae that are farther. You've got more type 1a supernovae that are even farther than that. And from those different time slices of the universe, you can measure how fast these things are spreading apart. And from there, you can measure the amount of matter that is in the universe that is essentially decelerating this expansion of the universe. And they were able to measure the accuracy of the dark matter and the matter. You know, we know how much matter there is because we can count it, we can see it. You add up all the galaxies, you measure the gas in between. That gets you one number, and then the rest is dark matter, the stuff you can't see. And again, they were able to measure this to 5 sigma accuracy. And the thing that's really weird is at about the 7-8 billion year mark, when you would be expecting the universe to be slowing down on this very smooth curve, it starts to speed up and just is going faster and faster and faster. And this is dark energy. And the first discovery was made back in 1998 using type 1a supernovae. And now with this modern measurement, again, we're at 5 sigma accuracy. So there's a 1 in 3.6 million chance that there is no dark energy. And that's just one line of evidence. I mean, you can look at galaxy rotation curves. You can look at the signal in the cosmic microwave background radiation. You can look at gravitational lensing from clusters as matter is lensing the light from more distant objects. There's many, many independent lines of evidence that show that dark matter and dark energy are there. Nobody knows what they are. And that's fine. Like, one thing at a time. Right? Let's figure out that this thing exists, or that these things exist, that these things are present in the universe, that there are mysteries that need solving. And once you get to that point, then comes the let's figure out what they are. Let's launch the Nancy Grace Roman Space Telescope, which is designed to measure the expansion rate of the universe at a level of accuracy that's never been seen before. Let's build the Vera Rubin Observatory, which is going to be mapping not 1,500 supernova, but 1 million supernova to, again, measure the accuracy of the expansion of the universe at different times in its history. And then let's examine the universe in gravitational waves. Let's examine the universe in neutrinos. Each one of these different ways of looking at the universe gets us closer, if not answering what they are, at least parameterizing, understanding their impact and influence on the universe, and starting to reject various ideas for what they could be. And it might be, again, that we never know what they are, but it might be that after a while, you've rejected every possible idea, and whatever remains is the most likely, the one that has the most evidence for it. James Bean, are there any plans for a new cosmic microwave background mission as with Hubble and JWST? Could there be a more advanced probe of the cosmic microwave background? Is there more that could be observed? So there's actually a limit. So the most recent spacecraft is called the Planck satellite, and it did the one that gives us that 13.78 billion year age of the universe. And it's actually pretty much at the limit of what we can measure in the what are called the anisotropies, the temperature differences in the cosmic microwave background. There isn't much more data that can be gleaned from that view. There's other information like the polarization of the cosmic microwave background and maybe other kinds of signals that are embedded within that. But kind of the key to Planck was that it was like the best possible measurement that the laws of physics allow. So there probably won't be something like that. But I mean, there's tons and tons of information that is closer that we're going to need to figure out. The Fermi telescope is sort of going to be probably the next big one. The Gamma Ray Large Area, I think that's the one. No, not the Fermi. The Plato? I think it's Plato. The Plato mission. No, that's not it either. So it is the Fermi. Yeah. So anyway, so weirdly, there's no real reason to make another cosmic microwave background. The Masterston on Modern Warfare 2, what's the quickest way to unlock the red dot sight? I don't know. Modern Warfare 2. I played that. I finished that with my son. It's a good game. Although we mostly played the horde mode where you fight lots of people attacking you as a team, which I really like. Has Fraser seen or heard about the Earther Bob Nodell Globusters attempt at rebutting Fraser's James Webb vid? No. I hope they had fun. Whoops, that was a mistake. What did I do with it? Okay, all right. Okay. Nate King. If the background microwave radiation at the edge of our observable universe was generated during the Big Bang, how could there be anything past that point? So when we see the cosmic microwave background, we are seeing the universe as it looked 13.8 billion years. The light that was released at the cosmic microwave background has been traveling for 13.8 billion years. Well, 380,000 years after the Big Bang, the beginning of the universe. And it is the farthest that we can see in radiation because at that point, the entire universe was effectively like a red giant star and was ionized. And so the light couldn't escape. And then finally, you got this point where light could finally escape out into the universe. And so every second that goes by, every minute that goes by, we are seeing the new region of space that is releasing this light for the first time. There's like this expanding sphere around us where the universe is releasing their first light. And then the next, a minute later, a little bit farther, and it's releasing its first light. And then a minute later, another bigger sphere, and it's releasing its first light. So that's because, but that's the only reason that's the case is because light takes time. Light moves a light year per year. And so that's not what the universe is really like. The universe might very well be infinite. And so if you travel a billion light years, 10 billion light years in any direction, you're going to see a modern mature universe like we have here today. Spiral galaxies, gas, supermassive black holes, planets, etc. in all directions. Maybe forever. And so it's like the universe was infinite back then, and the universe is infinite now. It's just that it has taken time for the light to reach us. And so we can just never see the universe as it looks today because of the light travel time. So, I mean, how could there be anything past that point? Like, are you asking, like, how could there be anything past the cosmic microwave? Well, we know via math and an understanding of physics, how the universe would have behaved at denser and denser points earlier on in time. But you get to the 0 point, and then our understanding, our physics stop. We have no way to proceed to understand what was there before, or if there was anything there before, or if it was the beginning of time and space or anything. So it's a time issue which sets one of the limits in the universe as the earliest point in the universe, but not a distance. Was the Psyche mission canceled? No, Psyche was given the green light last week. So no, Psyche is on, which is great. JP, how will AI affect the future of astronomy? AI is already having a dramatic impact in the future of astronomy. And like in the olden days, if you wanted to study the spectra of 1,000 galaxies, you would have to lean on an army of grad students. And it was unfun work at the best, that you would have to sit down and study these galaxies one at a time and produce all of this data. And then for a while there were some challenges that like human beings were really good at, like identifying which direction a galaxy is rotating, but were actually pretty difficult for a computer to figure out. And so we had this rise of citizen science projects, Galaxy Zoo, the work that we do at CosmoQuest, counting craters, searching for Kuiper Belt objects, that kind of thing. But artificial intelligence has been making some incredible strides in astronomy. We're getting to the point now where like we're seeing artificial intelligence discover planets in data, that you give it enough information about what a planet looks like in the data, and then it goes and examines the brightness data of millions of star systems, and it finds new planets or new planetary candidates. That they're starting to characterize galaxies in a way that used to require human beings at a massive scale. So astronomy is a data game, is about collecting enormous amounts of data and then attempting to study that data. And the modern form of telescopes, you think about the Vera Rubin Observatory, which is going to be dumping, I forget, exabytes, petabytes of data onto the internet on a monthly basis. No human being can go through this much data, but a computer can. And so if you can properly train with machine learning, I mean, it's not exactly artificial intelligence, so like don't send me the angry emails, but if you can properly train an algorithm to recognize what a galaxy is, or a certain kind of nebula, or a certain kind of star, or a supernova, or whatever, or an asteroid, or so on, then you can have them go and crunch through data with a lot of accuracy. So, I mean, not only will the future really involve machine learning, it's going to depend on it to really make any meaningful. Like, how do you study the atmosphere of 50 million exoplanets without leaning on a machine learning algorithm to do it? So, they took our jobs. Europa neutrino detector when? Like, just turn all of Europa into a neutrino detector? That would be awesome. I love that idea. Dico Ravanto, what happened to Project Starship? Many people thought it was legit back then, right? It's a science fiction idea. Like, theoretically, firing a laser at a incredibly thin mylar solar sail to accelerate it to a significant fraction of the speed of light and send it off to another star system, it's theoretically possible, but there are so many pieces of that technology stack that don't exist yet. So don't be surprised if nothing's happening. You know, we're seeing various pieces of it be developed and tested bit by bit. I've seen some people develop miniaturization of the spacecraft payload. I've seen research in more powerful lasers. I've seen interesting ideas about solar sails, but it is going to be a multi-generational technology to carry out, which sucks. But, we're going to know that it's happening when we see multiple spacecraft, like star shots being sent here in the solar system, because the same technology is actually far easier to pull off in the solar system and use. I don't even know what a Rydberg state is. What is the funkiest nebula? God, how do you describe funk? How do you measure funk in a nebula? Karate Master. Fraser, would you get yourself cryogenically frozen and then asked to be thawed out in a couple of 100 years? Like, if it was safe, then absolutely. Like, if I knew that it would work and that after I died I could be cryogenically frozen, and then someone wasn't going to just forget and let me thaw out and rot in a tube somewhere, then yeah, I would do that. I like the idea. I'm excited about the future. And I would love to see, people always ask me this question, right? Like, would you rather live in the past or would you like to live in the future? Future. Like, obviously we have some challenges, so like maybe after the climate wars. But I am pretty excited about all of this technology. And like after the robot uprising, after the global pandemic, the genetically engineered pandemic, then you can unthaw me. When we've made peace with the robots, when we've outlawed the technology to do gene splicing to create your own pandemics, and then after the whole planet is carbon neutral, that's when I'd like to see what the future looks like. But no, I'm excited about the future. And like, when I think about my career, the kinds of stories that I am excited about, the kinds of things that I gravitate towards, are stuff that's in the future, but is tangible, that's doable, stuff that's in the near future. New ideas for telescopes, new ideas for missions, interesting ideas to solve vexing astronomical challenges. I'm excited about the future. I always have been, and I would love to see what happens next. I'm an early adopter about everything. But would I get myself cryogenically frozen now if I knew that it was 100% safe and I could see the future? Maybe. I know my wife would. So if we could do it together, probably. Yeah. All right. All right, so that's the end of this. I'm going to record I'm going to do the post-production stuff, and then we will stick around for after time. So don't go anywhere. Extra time. Overtime. What? Sorry, I gotta fix something. One more. Okay. Okay. Let's try this. If you like my answers to your questions, as well as other things that we do at Universe Today, consider joining our Patreon club. You'll get an ad-free experience on universetoday.com for life, even if you unsubscribe. And you'll get ad-free videos, early access to interviews, as well as other perks that are exclusive to our Patreon community. Thanks to everyone who already subscribed, and welcome to the recent newcomers. Keith, Brian, Lewis, Richard Lowe, Katron Van der Hayden, Katrian. All right. Keith, Brian, Lewis, Richard Lowe, Katrian Van der Hayden, Paul Lucas, Roger Reynolds, David E. Odell, Sapjez, Charles Roche, Girolamo Costaldo. Join the club at patreon.com/universetoday. Okay, those are all the questions that we had this week. Thank you, everyone, for hanging out. Don't forget to vote in the comments below for the question you thought was the best. Remember, we record these shows every Monday at 5 p.m. Pacific time. So if you want to join the show, put in some kind of like notification, click the notification bell, subscribe, all of the YouTube stuff, and we'll see you on the live show or on the next question show. Thanks, everyone. If you want to stay on top of all the important space news, join my weekly email newsletter. I send it out every Friday to more than 55,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, interstellar adventurers, and the galaxy wanderers. And a special thanks to Josh Schultz and Andrew M. Gross, who support us at the Master of the Universe level. All your support means the universe to us. All right, let me stop this. And stop that. All right. Chris Hipser is fanboying right now. Okay, so there's a question there that I wanted to tackle, which I thought was really interesting. God, there's so many good questions. Pete Edwards says, Fraser, you should review these question streams and do a more considered answers show occasionally. So can you give me some more information about what it is that you're hoping for? Like, are you saying that I'm doing a bad job of the question show? Or are you saying like there are questions that I'm not answering because I don't know the answers to them, that maybe with some research I could do the answer? Or, yeah, I'd be interested. Can you expand on the comment just so I can get a better sense of what it is that you are mentioning? I mean, I think that, there's a cycle here that you probably don't see when we're doing this, right? Like during the live shows, I'm picking questions that I feel like I know the answers to, obviously, right? I'm staying well within my wheelhouse. But the questions that you ask that I don't know the answers to sort of sticks in my subconscious, and I ruminate about them and I think about them. And then what I do is I schedule interviews with scientists who do know the answers to those questions. And so when you listen to the interview, which of course you do, why wouldn't you? I am pushing the boundaries of my knowledge. And I'm specifically asking the kinds of questions that I don't know the answers to, that in many cases were asked by you. And I think that's an interesting cycle to go through. With the QAs, with the space bites, it's all stuff that I know the answers to. But the interviews are the stuff that I don't know the answers to on purpose. And I find that really exciting. And I don't know where the conversation is going to go. And I'm also trying to fast forward through all the stuff that we all know about this to the little edge, to the cutting edge, to the bleeding edge that we don't know. And I hope that comes through. So, but yeah, I'd be interested to know, obviously, always how I can make this better. But I like the vibe. It's hard to describe, but I really enjoy, and that's why I queue some questions up in advance, because in many cases I'm gonna prepare some notes. I'm going to double check some questions to make sure that I've got the right information. But I really enjoy the vibe of the live show. It's exciting to not know the questions that are coming my way. So if other people have opinions of that, that would be great. Chris Hipster, how many? Geez, the chronograph interview. Just how much more in depth can an interview be? Yeah, that's the key. Like they are as in depth as I can go with the question. And then Pete Edwards, for example, you research the science projects, but even though you might not know the answer, you come across people who do. See, I think that's the interviews. Like the interviews is me pushing my understanding out. And then I'm sure you've noticed this. I will discover something in an interview, like my whole diatribe about dark matter today and dark energy, and then I digest it and then I regurgitate it like I'm feeding a baby bird. Not that you're a baby bird, but you know what I mean. Steve Ross, maybe I'm alone, but I think that a lot of people are interested in what the upcoming active solar cycle means for us. Is another Carrington event likely possible? Another Carrington event is inevitable. Like it's only a couple hundred years ago, 1859, that we had the last Carrington event. So that's less than 200 years ago. So the chances are that's going to happen again. Do you want to hear something really unnerving? It's Halloween. I'm allowed to scare you, right? So researchers have gone and looked at tree rings, and they essentially can see when there are large deposits of carbon-14 taken up by the tree. And that carbon-14 is released into the atmosphere when really powerful solar storms hit like some kind of radiation storm hits the atmosphere, creates this giant population of carbon-14 that gets sucked into the tree, and you get these very specific points. And for the oldest trees that are out there on Earth, there have been 6 events that were powerful enough that you could see the signal in the tree rings. You can't see the Carrington event. It doesn't register as one of the more powerful solar storms that have hit the Earth in the last 10,000 years. It doesn't even register. That's scary, right? Like the thing that set telegraph poles on fire, the thing that made the auroras visible from the equator, did not generate enough carbon-14 in the atmosphere to create a detectable signal in tree rings. Anyway, I'm going to be interviewing the researcher behind that because I found it really exciting, and I hope you will too. Yeah, there you go. Happy Halloween. Sai Rohini Krishna Mandava. Hey Fraser, from what you know, which of our technology research will succeed first in enabling interstellar travel for humanity? So it's the for humanity part that is the key. There's really only 3 viable technologies for interstellar travel that don't break the laws of physics. Number 1 is fusion, but fusion is still very expensive in terms of mass. You'd have to have a really powerful rocket that could take you to another star system. A lot of fuel. You've got the sail, the laser sail. So you fire your spacecraft with a laser. It accelerates it to a significant portion of the speed of light. The problem is that it can't slow down. And so you're not able to arrive. So the only one that really makes sense is antimatter. And right now, antimatter costs $64 trillion a gram to make. That's expensive. So we will need a form of creating antimatter, and then we have no way to hold the antimatter. But if you could generate enough antimatter, then you could travel between star systems, which is pretty cool. So antimatter is going to be the way. But then you said, like, what about setting humans? Humans will never go to other star systems. Like, I'm calling it now. Like, I know that sucks to hear. We'll send our robots. If we really get ambitious, we'll send factories with DNA, and maybe we'll try to release microorganisms in other star systems. But we're just too soft and fleshy to go to make the journey. Now, it could very well be that we'll come up with some amazing technology and be able to live that sci-fi future. But Star Trek, Star Wars, they're fiction. They're boat stories. They're not an actual sort of chilling vision of the future. Tony, disclosure soon? No, there will be no disclosure because there is no conspiracy. It's cool. There's a I think the U.S. Reconnaissance Office is going to be providing a bunch more information about UAPs in a couple of days, and I think we're going to be reporting on that. And then NASA has convened a team of 16 experts who will be studying NASA data for evidence of UAPs. And like the names in there have got to tell you how this is going to play out, right? You've got Scott Kelly. You've got David Grinspoon, Dr. Funky Spoon, who is a renowned scientist, author, skeptic. So like the list is a who's who of scientists. They're going to do a really good job of not finding anything. So there's like every single UFO sighting has a plausible explanation. It's a weather balloon. It's a reflection off of an infrared camera. It is Venus. It is a drone. It is a out of focus night sight. And if you would like, what would be the purpose of aliens flying to the solar system across the vast gulf of the universe and just like zipping around the sky so that people could spot them? Like, you would go to eradicate life on the planet. You would go to bring that other star system into your galactic federation. You would go to extract the resources from that planetary system at an incomprehensible scale. It's just bizarre to me that people could think of any reason. So as long as there is a perfectly, like until we have an artifact, until we have something that we can just like actually check, at the very best, it will be a UFO, an unidentified, keyword unidentified, flying object. It's an object, maybe. It's flying, it's in the air, okay, it's unidentified. Well, you can, as I say, you can't unidentify yourself to knowledge. So, like, you could probably get me to agree that it is unidentified. But if you are saying that it is aliens, and you're waiting for the disclosure of the aliens, you will wait a long time. So, yeah. Never. Disclosure never. And like, the government report is going to come out in a couple of days, and it's going to say it's not aliens. And we don't, and we know what these 7 things are, but we don't know what those 4 things are. And then the NASA one's going to come out, and it's going to say, we have no evidence that it's aliens. We know what these 17 things are, but we don't know what those 42 things are. And that'll just be the story forever until, we're flying to other star systems and aliens are wondering why we're making circles in their fields. But I can't wait to be wrong. Like, I just gotta, like, please Show me to be wrong, because like being wrong would be the best thing ever. That we would see evidence of aliens that are here, that there are aliens out there in the universe. People always say like, oh, you can't handle the truth. I can handle the truth. I'm ready. I've never been more ready. Please provide me with unambiguous evidence that we live in a universe with lots of other alien civilizations and they come to Earth, and God, that would be the best. And so, yeah, yes, please. Okay. Let's see. Louis Throttler, how psyched are you about the Psyche mission? It's an alien planetary core. Surely there's a massive amount to learn from it. Yeah, so the Psyche mission, right? This is going to be a mission that's going to be going to this asteroid that is made of metal. I have a metal asteroid or metal meteorite back there. I don't know if you can see it. It's a pound of alien space metal, and it's so cool. Like it just like if you can buy a metal meteorite, you will be so happy with it, and they're not that expensive. The Campos del Cielo meteorites, you can buy them for $50 for something you can hold in your hand and know is a piece of space metal. But like to go and see, and it probably won't look like a shining chrome asteroid, although that would be the best. But it could have metal volcanoes, which is something that we don't see anywhere else in the solar system. So yeah, I mean, it is only 15% of asteroids are of this family, and none have ever been visited up close. And so it is an entire classification of, and yet there are like, we have impact sites here on Earth, like in Canada and Sudbury, or the, is it Allen? No, Meteor Crater, Barringer Crater in Arizona. A metal meteorite struck the Earth. So yeah, I'm so glad that the mission has been uncanceled. Luke Carter, where can I buy some space metal meteorite from a reputable source? So, I mean, you can get them from eBay and like do a search on eBay and search for like metal meteorite or Campos, the one that is the most common. There's like 1,000 times as much of the Campos del Cielo meteorite than really any other type. Do I have some of them? Maybe. Let's see. Back here. I do, right? Yeah. Okay. So let's see. Block out oh great, break my desk. Okay. So I buy these. There, let's see. Okay. There. So these are, right, I give them away as gifts when I meet people. Like Nancy, you've got one, don't you? So, and you can buy them in bulk on eBay. You can get smaller ones and bigger ones. And so what happens is there is a, okay. All right. There's a, yeah. So like there's people they're in Argentina and people are finding them all the time and then selling them on eBay, and there's brokers and other stuff. Now there are people who are, like scamming, and they're selling slag from factories and stuff, so you got to be really careful. And certificates of authenticity are good. Positive seller ratings are good. So, but if you want to be absolutely sure, then I would go to Aerolite meteors. Is that right? Yeah, Aerolite. Aerolite. And that's Jeff Notkin's. So, the meteor hunters. That's his company. And that's where I got mine from, my big one. Again, let me get my eyes out of it. There you go. And it's heavy. And it's about, my wife got it for me as a gift. Put it beside me. It's about like $250, I think. So that's the way to go if you want to be absolutely sure, is go to like Aerolite and drop a couple $100 and get a proper meteorite, and you will be so happy. So, it's expensive, but I mean, computers are expensive. Phones are expensive. All right. Oh, my wife just sent me a message. Okay. All right. I gotta go. Dinner's ready. I'm going to roll. But thank you, everyone, for hanging out this week. That was super fun. Please have a nice, safe Halloween. Thanks to Nancy, of course, for coordinating all the questions. Nancy, you're the best. Appreciate it. And thank you to all of the other moderators who hung out. Thanks for everyone who asked questions. That was super fun. And we've got lots and lots of cool content coming out this week. So stay tuned. All right. Andy Saunders, I've already interviewed him. That's right. For the weekly Space Hangout this week. Cool list. All right. Thanks, everyone. We'll see you next week. Now press the don't button.